Hello, welcome back to uh, how to solve the permeability in a stratified soil. We have already calculated the head difference for this particular problem in order for the flow to maintain at 500 centimeter cube uh, per second, and what is the head difference that we needed, and we already found that it is 12.9 centimeter. Now the question here for the part B, it says that to maintain the same flow rate, what should be the value of HA and HB? And what it means is that what is this height HA from the datum, and what is the height of water that it will go for HB from the datum. So here you'll see that if I remove all this, okay. So here the question says that we already know that this is 12.9 centimeter from the datum. So the question asks here that what is this HA? So now if we have to use Q equal to KIA, remember that I is your head difference divided by length. So the head loss or head difference. So in this particular problem is this will be your delta HA, okay, which is your head loss. So in order for the water to flow through soil A, there will be a head loss or head difference of delta HA. So now your I will be equal to delta HA over LA. So for this, so delta HA, which means that it will be 12.9 minus HA divided by 150 millimeter, which is equal to 12.9 minus HA 15 centimeter, because we want to work with the consistent unit, which is centimeter. So the question is, what will be the HA? So we can use the same um, formula that we have already applied, which is Q equal to KIA. So we know that for part B, Q is equal to Ka, because we are the water is flowing through soil A, and will be 12.9 minus HA divided by length of A, the length of soil A, into area of A. Because the area is the same for the soil, so we're going to just use A. And so this is 0.139 centimeter cube per second, and Ka is of the soil A is 10 to the power minus 2 centimeter per second, and that will be 12.9 minus HA divided by length of soil is 15 centimeter, and the area is 400 centimeter square. And so HA will be equal to 12.379 centimeter. So that is your HA, 12.379. So which means that this HA will be equal to 12.379 centimeter, which means that it will rise to 12.379 centimeter. And now the question it asks is, what should be HB if it has to maintain the same flow rate? What should be the value HB? So here you'll see that for the water to flow from to flow through soil B, your head loss will be delta HB. Or you can also say that, or you can say that for water flowing through soil C, we are talking about soil C, your head loss will be itself H delta HC, delta HC, which is equal to HB. So you can solve this problem in two ways. Either you calculated the soil flowing through B, which will be delta HB, the head loss, or you can calculate the soil passing through soil C, which is your delta HC, which is equal to HB. So you can, for this particular problem, is you can either solve HB, or you can either solve the water flowing through soil B, or you can either solve the water flowing through soil C, and the value will be almost the same. So for delta HB will be, or for this delta HB will be, let's see. Okay. So for here you can either use um, QB. Q is equal to KB delta HB LB area, or Q is equal to KC delta HC divided by LC into A. And you'll see that KB, if you look at delta HB here will be equal to HA minus HB. And so for delta HB will be HA minus HB divided by 15 centimeter into 400 centimeter square. And for our Q is equal to Kc, which is here your H for Kc, for delta Hc. We already say that delta Hc is equal to itself Hb, because this is the head loss for the water to flow from through soil C. So through all this soil C, the head loss will be from here till here. So for that, we know that will be the head loss at this point and head loss at this point. And since this is the datum at this point, it is a datum, so your H will be there. Your head energy at this level or at the datum will be equal to 0. So your head loss will be HB minus 0 will be HB itself. So here you'll be HB divided by 15 centimeter and multiply with 400 centimeters square. So we're going to, so you can see that both of them will give you the same value. So we're going to pick up only the H through HB, 139 centimeter cube per second is equal to KB, which is 3 into 10 to the power minus 3 centimeter per second, and HA is 12.379 minus HB divided by 15 centimeter and multiply with 4 centimeters square, and you'll find that your HB is equal to 10.642 centimeter. So this HB will be equal to 10.642 centimeter. So that is all how you solve the problem of permeability in a stratified soil. Thank you.